1,700-year-old Korean genomes show genetic heterogeneity in 3 kingdoms period Gaya. This is by University of Vienna on phys.org. 2 males on top, AKG 10218, AKG 10203, and 2 females on the bottom, AKG 3420, AKG 10207. An international team led by University of Vienna and the Ulsan National Institute of Science and Technology in collaboration with the National Museum of Korea has successfully sequenced and studied the whole genome of 8 1,700-year-old individuals dated to the 3 kingdoms prior to Korea. That's about 57 BC to 668 AD. The first published genomes from this period in Korea bring key information for the understanding of Korean population history. The team has been led by Per Gelibert and Professor Ron Pinhasi of the University of Vienna, together with Professor Jong Bak and Asta Blazit from the UNIST, Professor Kim Dong-bai from the National Museum of Korea. The study, published in Current Biology, showed that ancient Koreans from the Gaya Confederacy were more diverse than present-day Korean population. The 8 ancient skeleton remains used for DNA extraction and bioinformatic analysis came from the Daesung Dong Tumuli. The tumuli means a tomb, like a mound, the iconic funerary complex of the Gaya Confederacy, and from Yuhari Shell Mound, both archaeological sites located in Gimhae, South Korea. Some of the 8 studied individuals were identified as tomb owners, others as human sacrifices, and one, a child, was buried in a shell mound, a typical funerary monument of Southeast Asia that's not related to privileged individuals. All burial sites are typical for the Gaya region funerary practices in AD 300 to 500. Quote, the individual genetic differences are not correlated to the grave topology, indicating that the social status in the 3 kingdoms Korea would not be related to genetic ancestry. We have observed that there is no clear genetic difference between the grave owners and the human sacrifices, explains anthropologist Pierre Gelibert. 6 out of 8 ancient individuals were genetically closer to modern Koreans, modern Japanese, Kofun genomes are contemporaneously with individuals from the study, and Neolithic Koreans. The genomes of the remaining 2 were slightly closer to modern Japanese and ancient Japanese Jomons. This means that in the past, the Korean peninsula showed more genetic diversity than in our time, says Gelibert. Modern Koreans, on the other hand, appear to have lost this Jomon-related genetic component owing to a relative genetic isolation that followed the 3 kingdoms period. These results support a well-documented post-3 kingdoms period Korean history, suggesting that Koreans of that time were intermixing within the peninsula and their genetic differences were diminished until the Korean population became homogeneous as we know it today. The detailed DNA-based facial feature prediction of the 8 genomes showed that the 3 kingdom periods Koreans resembled modern Koreans. This is the first instance of publishing an ancient individual's face prediction using DNA only. This approach may create a precedent for other ancient genome studies to predict facial features when the skulls are extremely degraded. So this is by University of Vienna on phys.org. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.